Hello everyone and welcome to another solution video for HSMA. This is going to be the solution video for exercise 5 of HSMA session 1E, the first Python session, and this is the last exercise we're going to be going through. And what is this exercise? Well, it's Are You Smarter Than Dan as a 4-year-old? So this program we will be creating is going to replicate a program that Dan, our instructor, created when he was 4. In this game, the computer will randomly pick a whole number between 1 and 100. And what will happen then is the user has 10 chances to guess what the number is. Depending on what they guess, it will compare against the number that the computer picked and choose whether, or tell the user whether the number was too low, too high, or whether they're actually correct. You will get 10 guesses, so then you'll be told you've lost, and that the game will end if you haven't correctly identified what the number is. We've also been asked to add a couple of extra features in that didn't exist in this original game. So what I'm going to kick off by doing is creating anything that I think I need to be storing. So what do I want to be storing? I want to be probably tracking how many turns the user has had. So I'm going to start off by making a number of turns. I'm going to say that to begin with, this number of turns is going to be 0. I'm going to put these within loops and the like later on, but just for my own way of thinking, I find it quite helpful to sit down and go, what am I actually wanting to be keeping track of? So we need to know, we also need to know what the computer's chosen number is. And actually to do this, I'm going to be using something called the random library. So I'm going to open up a new code cell. So I did this by hovering over my existing code cell and choosing plus code. And I'm going to import the random library. I'm going to do it in a separate code cell because I only really need to do this once and it's not really worth me doing this multiple times and running it each time we create a new code cell. So I'm going to run that. I've already entered my base environment. We're using Anaconda, of course, in this course, and therefore I've selected base because that's got lots of nice, lovely packages already installed. But random actually should be installed regardless of what you're using. It's a sort of core part of Python. You don't need to install it separately. It just doesn't get imported every time you open up Python because otherwise it would be a little bit wasteful. It would make your programs more bloated than they need to be. So what I'm going to have is the computer chosen number, and I'm going to use a function of the random library called randint. Now the nice thing about randint is it allows us to get the computer to pick a random number between 1 and 100, and I'm going to print computer chosen number, and then I will just keep running this. Now you can see, unfortunately, I'm getting lots of funny little errors showing up in my VS Code. It's running a little bit slowly today. I'm not really sure why, but if you see some funny error messages popping up, that is why. So I'm going to execute the cell, and hopefully, yep, we've had 28 printed. If I run this again, it'll think about it. Still getting 28. Why is that? Oh, this time we've got 58. Run it again, 42, excellent number, 14, 2. So what you can see is every time we run this little bit of code, what we're getting is a new random number. Now, how do we know we're getting between 1 and 100? Well, the first parameter in our randint is the first eligible number that the computer could pick from. 100 is the highest eligible number it could pick from. If I hover over randint, it's going to think about it for a little while because, as I say, things are really running a little bit slowly today. Let's see if I can get this to come up. Unfortunately, it doesn't seem to be playing ball. What I would usually get when this happens is a little pop-up telling me what I might want to know about the randint function. So I'm going to go and do this in Google, in Firefox instead, in my web browser. So let's look up randint function Python. I'm just searching this over here and I'll bring this over, and you can see there's a couple of different solutions that have come up here. So we've got the W3 Schools. It's a nice website, actually, really great place to refresh yourself on any aspect of Python. But I'm going to scroll down until I find the Python docs. And I'm going to Control F search for rand int in this case. And what we can see we get is random.randint, return a random integer n such that a is less than or equal to n and less than or equal to b. So all this means is that the random integer it returns can be anything equal to or higher than integer a that we put in, and anything equal to or lower than integer b. It's always worth checking these things because it's not necessarily consistent. You might remember when we were doing some slicing of lists that actually it didn't include the second number in our slice, so actually it would go up to list index 5, but it wouldn't actually include list index 5 if we put 5. So it's always just worth checking the behavior of functions like this when you are coding. So what else do we need to be storing? We want to be an empty list of user guesses. So I'm going to call this user guesses list. I find it quite helpful to mention what kind of variable I'm storing sometimes, particularly when it's a list. It's very handy to be able to remember what you are using. So rather than just calling it user guesses in this case. We'll be asking whether the user wants to play again after every game ends. So we probably want to have some way of tracking whether the user wants to continue playing or not. So actually let's make a Boolean variable and we're going to call that continue play. And we're going to set that to true to begin with because we're going to assume that when the user starts the game, they actually do want to play it. And until they tell us otherwise, we will continue to make them play. So what do we want other than that? I think, one of the other things we want to store is these users' score. So actually we want to store both the score, which is set to 1,000 by default, and we want to store the high score. Now the high score will start off at 0 and then later on we'll replace it with whatever the score is. Now I'm not going to leave all of these at this level of indentation. We're going to be working with various loops, so some of these may end up inside the loops where we'll first define them, but just to kind of have a first indication of what we want to be tracking, this is a good start. Now the first thing I'm going to do is actually start a while loop. And this while loop is going to be what we were saying about the user continuing to play. Until they tell us otherwise, we are going to make them keep playing. So while continue play equals true, we are going to do everything within this indented block of code. And basically all of our remaining code will probably be indented within this, apart from maybe we might do something like print the final high score at the end. We'll see if we want to do that when we get to that point. So let's start off by saying something like, what do we want to do? User has to So I think what we probably want to do is give the user a bit of an introduction to the game when they start up. So let's just print some messages for them. Let's go, welcome to guessing game. Ooh, I'm thinking number. And what we're then going to want to do is actually at this point we're going to want to set the users what the computer is thinking of. And actually let's do that when we first start up the game. There we go. So why are we doing that rather than leaving it outside? Well, otherwise we will only have a chosen number when we first start running our game. So when we go back through another round of the game, well, we'd still have the same number, not the hardest game in the world at that point. If we put it inside our while loop, every time we get back to the beginning of the while loop, it will choose a nice new number for the game. What we're going to do now is we are going to choose how many we're going to. Actually, no, let's get some user input. Let's go user guess. Oh, don't know why I'm trying to do colon there. So user guess is our good old friend integer input. Please enter a number. And let's have a look at what we do next. We would go, okay, if the user guess is equal to the computer's number. Then we're going to print, well done, you get it. And we're going to exit, probably. Are we going to exit there? Let's have a think about that. Yeah, I think we probably will exit at that point. Now, this is all going to be quite iterative because actually writing a more complex program like this often is. It's not always easy to think about the best way to do it all the way all at once. I find when I'm writing code, it's a process where I try things, I break things, I work out little bits of the code that needs to work, and then I add in the extra features as I go along. So all I'm caring about at the moment is getting in a user's guess. And actually, the logic of the next bit of the program might not work quite right yet. That's fine. We'll build up to that over time. And we might need to get rid of a bit of code. We might need to rewrite the way a few things work. That's entirely normal. You know, I don't find myself using while loops that often in my day-to-day, so I'm a little bit, when I get presented with a problem that requires while loops, it can take me a little while to think about the way that is best to do it. But let's carry on with writing these conditions. So if the user guess is actually less than the computer number, then let's say print u too low. Is that too low? Yeah, user guess is less than the user. And let's use an else actually, because to be honest, at this point, those are the only possibilities, or that the user didn't enter a valid number, in which case actually we're just going to error out at this point. It's not going to actually let us continue running, so we're not even going to run into that. Later on in the course, we'll talk about error handling, we'll talk about better ways to deal with that sort of scenario, but for now, we're just going to make the assumption that our users are going to be really nice and actually only enter valid numbers. So the only situations you can find yourself with two integer numbers is they're either equal, one is bigger than the other, or it's smaller than the other. So let's say we'll print 2i. What else did we need to do? So if the user guess is less than the user number, then actually that's a sort of fail scenario. So we are going to add in, we're going to detract from their score. So we could do score equals score minus 100. And that just means take whatever score the user has at this point in time. If they've just started, it will be 1,000, but later on in the game it could be lower, and minus 100 from it. There's a really nice little shorthand we can do where we just actually do equals minus equals. That's the wrong way around. So minus equals. Minus equals means just subtract 100 and assign it back to score. So score will at this point get lower. It's exactly the same as this. It is functionally does exactly the same thing. It's just a nice little shorthand. We're going to want to do the same if the number is too high. And the other thing we want to do when a user has guessed is we're going to want to actually add a counter. We're going to want to increment the number of guesses that the user has done. So we set up this number of turns equals 0 at the beginning. And we're going to do plus equals this time. So number of turns equals 1. The user has guessed and the number of turns is increased. So after one turn it will be 1, after 2 turns it will be 2, and in a minute we'll actually start checking to make sure that we haven't given the user an infinite number of turns. And the other thing I've realised while I'm doing that is actually, again, this bit of the code is continuing. This is almost a sort of per game bit of code. Now, what's happening when they get to the end of the game and start a new one? Well, this bit isn't running. This bit is almost entirely separate from our game. It's set up at the very beginning when the user first starts running the game. So what's going to happen? Well, they're going to have 10 turns. They're going to get to the end of the game, and then they're going to go back to the beginning, and they're going to be on turn 11, which is not what we want. We want to make sure that at the beginning of every game, we reset the number of turns. And we're also, to be honest, going to want to reset a few other things. We're going to want the user guess list to actually be set at the beginning of every game. We're going to want the score to be set at the beginning of every game. But what we're not going to want to set at the beginning of every game, and what we're only going to want to set once, is the high score of the user and whether they want to keep playing. because we'll be controlling this inside of our loop, and also we'll be keeping track of the high score, we'll be updating the high score, but we don't want to set the high score back to 0 at the beginning of every round of the game, otherwise it's not really a high score. So, I'm going to save this a second, and what I'm going to do as well is I'm going to, regardless of what the user does, I'm going to add their guess to our list of guesses. So this is nice and simple. User guess dot append user guess. User guesses list even. So before the append we say what list do I want you to add this to, and then please add the user guess to the user guesses list. So that will be adding it into our empty list that we defined here. And actually, if we've already got a number in the list, it will go next in the list. So we will gradually build up a list of all of the numbers. What do we want to do next? Let's see if we can get up to the point where at least we can run through a round of the game. So what logic have we got left to put in to make sure that happens? Well, I think it's the turn logic really, isn't it? Because at this point, they will, well, let's see what happens if we run. That's probably the easiest way to do it. So I'm going to run this code. Welcome to the guessing game. I'm thinking of a number. Please enter a number 3. And it's doing a little bit of thinking. And actually, computer number not defined. Oh, that's just an error actually. So you can see computer chosen number, and I have actually used computer number elsewhere. So we could go either way. Let's change it to computer chosen number. And we will save this. This would all be a lot easier if my VS Code wasn't having a little bit of a moment and deciding to error out rather than giving me useful error messages. So what shall we do next? So I'm running the code again. Please enter a number. I'm going to try 3 again. And it's thinking about it. Too low. And then it's just saying, welcome to the guessing game. So actually, we've hit this code again, which is not what we want. But let's try again. Let's try 7. And it's thinking about it still. I don't know. 6. Did you not like that number? Oh, and now we've got the last 2 have come out. Well, you can see that basically the code isn't really working, which we'd expect because we haven't really worked out we've worked out the logic of doing a single game. We haven't really done the logic of doing the number of turns that the user needs to do. So what am I going to do? I'm going to do a while loop here, and there's a couple of different ways we could do this actually. We could do a for loop. We could just say for however many guesses the user is allowed to have. We could make this number of turns actually, the user's allowed to have 10 turns. But I'm going to do it with a for loop just for fun. So I'm going to say for turn in range 10. So again, I think we've gone through this a little bit in the previous exercise if you want to go and recap your list. But what this means is anything inside this block will be run 10 times. So the whole block will be run and then it will go back through and run it again. So for turn in range 10, and actually to be honest, do we need to track this? I don't think we need to track this. I don't think we need to be tracking the number of turns at all in this case, because we're just going to do the logic this way. And this is what I mean. We will gradually start to tweak what our code is doing and how we're doing it. We might decide actually that was a better way to do it, but let's try. So for turn in range 10, let's see what happens if the user guesses chosen computer number, break and print well done, you guessed it. If the user guesses not the chosen computer number, then we'll print too low, and if the user number is that, we'll print too high. Also, just for our own testing purposes, I'm going to print a big message that says debug. I'm going to make it an F string so I can include a little bit of Python inside my printed output. And what I'm going to do is tell us what the chosen computer number is. Why is that? Because it'll make it a little bit easier for us to check that the game is actually working as intended. So I'm going to execute this cell. Have I called it something wrong? Computer chosen computer number. Yep, I've called it the wrong thing. There we are. If I paste that in, give it a moment to think about it, we've now got the right variable name being used throughout. Welcome to the game. I'm thinking of a number. So we've been told that the computer's number is 20. I'm going to guess 10. Oh, and what we've done is we have rushed through the whole game to the end, and the computer is now thinking of the number 5. Now, why is that happening? It's because after each turn, we're not giving the user a chance to re-enter their guess, are we? We're just going in and saying, here is the user's guess, and just keep comparing it. Don't let them do a new guess. Do 10 turns with the same number, which is not going to really work, is it? So what I'm going to do is I'm going to move this logic for choosing a number inside, and I'm going to also do this logic where we actually... Oh wait, no, excuse me, I'm not going to do that. We don't want the computer to choose a new number after every turn, or that's also a very difficult game. However, what we do want to do is when the user guesses a number, we're going to get them to enter a number inside each turn, and we're going to add that number to the list. There. Right. So what can we do now? I am going to run this again and see if it works a little bit better. So, welcome to the guessing game. I'm thinking of a number. The computer's number is 89, so again I'm just going to guess 10 for now. And I'm just being told to please enter a number. Let's try 20. For some reason we're not getting this printout of too low and too high. I think that might just be my computer lagging a little bit. And I'm going to now enter a number that's too high, so let's enter 105, and you can see actually our last guess has just come through along with too high, and what I'm finally going to do is guess 89. And oh, why have we not had any error message, anything pop through? I'm just going to enter 1 just for the sake of it, just to push this error message through. I think this is something that actually was mentioned during the sessions. There is sometimes a bit of a delay, and we're not really sure why. This is maybe why Python hasn't really taken off in the guessing game market. So what have we got? We got too low, too low, too high. Well done, you guessed it. Welcome to the guessing game. I'm thinking of a number. Now, we have actually we've got the core logic of the game working now. So I'm going to press escape because at the moment I haven't given the user a chance to actually leave. If they may never exit our game. So the first thing I'm going to do is ask for some more user input, and you can see I'm doing this outside of the turn logic. If the user correctly guesses, we will escape this bit of the code anyway, and we will go to whatever is written here. If the user doesn't guess correctly, then they will just gradually get to the end of this, and they will get to the end of this section, and we can then do, well, what's their score? Well, it doesn't really matter because if oh no, it does matter. So for turn in range 10, what we'll do we need to print the score regardless? Displayed if the user wins. So actually I'm going to go print, well done, you guessed it, your score was score. And I need to make this an F string, otherwise we'll just get it printing your score was score and not actually the score. But the nice thing here is by putting it in this little bit, if the user guesses are wrong, then we won't have to worry about printing the score. All we have to worry about is making the score less. Now, when we get to the end of our 10 turns, or when we guess correctly and escape this loop through that route, we want to print... well, let's first check... go print old high score or print... Well, let's go no, high score. Let's add a little bit of extra logic. Dan said we could add some bells and whistles. So if score is greater than high score, print new high score. And then we will change the high score, which we set up as 0 at the beginning, to be our current score from the user. And to be honest, if they got to the end and they did all their guesses, well, the score's actually going to be 0, so we won't this won't trigger. And otherwise, then actually we can print, let's say, else you didn't beat the high score, and we'll print what the high score was. Now, that still doesn't let us escape the everlasting loop of the game. So what we're going to do is give the user a chance to run away. So user guess, I'm just going to copy and paste this because all I need to do is a little bit of user input. And what I'm going to do is keep playing input and say, please enter Y to keep playing or N to leave. Now, what we're going to get is YN or something else that the computer doesn't really know what to do with. For now, just for the sake of simplicity and keeping this video fairly short, I'm going to do keep playing if keep playing input equals Y. I'm going to, what I'm going to do is actually set the continue play variable to, well, I'm not going to change anything. Because actually the keep playing is already true. So instead, I'm just going to check if keep playing input is N, then I'm going to put keep, what was the variable called? Continue play equals false. So remember 2 equals here because we're checking if keep playing input is equal to N, and 1 equals here because we are going to set the variable. We're setting the value, not comparing. So if the user chooses N, then we're going to do something. If they enter Y, well, to be honest, they want to keep playing. And if they enter Y, if they enter something that isn't Y and ignored our wishes, well, let's just make them keep playing anyway. We'll make them do another run of the game. So let's see what we've done so far. Did we? Yeah, we got told correct. Let's just change that to correct because it matches the brief. If the user uses all 10 chances without guessing, then so we do actually need to check that the user has whether they correctly guessed or not. So I'm going to make a new variable, guessed correctly equals false. And again, we're setting this at the beginning of each new run of the game. So let's say if they guess correctly, then we're going to set guess true. And at that point, I'm going to go here, and if they guessed correctly, what was it? If not guessed correctly, this is another way of writing if guessed correctly is false, if I'm remembering that correctly. So if not guessed correctly, I find that a little bit easier to read, then print you lose. Now, let's just go back through the logic of that. So guess correctly is set to false by default. The user will be iterating through their turns. If they guess correctly will be set to true, and we will exit out of this loop where they are looping through and entering their guesses. At this point, we will then check whether they guessed correctly or not, and if they didn't, then we will print you lose. And then we'll go on and do these other things. Did we print the high score, etc. There's lots of ways we could tidy this code up, make it a little bit better, make it a little bit more efficient, but this works absolutely fine, I think. Let's just verify if that is the case. So number is 62. So what I'm going to do is actually I'm going to keep guessing wrong. 1, 2, 3, 4. It's taking a little while to run, so it's a bit of a slow one to practice or to test, unfortunately. We could have changed it so that we only had 3 guesses, so that might have made it a little bit quicker, and I might do that in a minute. So I've got down to 2. How many have I got left? Oh, and I've got please enter Y to keep playing or N to leave. And again, I think this is this lagging problem. I'm going to press N because I want to leave at this point. We didn't beat the high score and we lost. The high score, oh, I forgot to put that F string in after all of that. So the high score just printed as curly braces high score. So that F string will fix that. It will now actually process that. So anything else we needed to do? We needed to do the score. We need to store the guesses in a list and print once the game is over. We are asking whether they want to play again after every game ends, and after each game, the player score is checked against the current high score and will replace the high score if it's better. So let us. We need to print the user's guesses, regardless of what they got. So let's go. Your guesses were guesses list. And remember, every time the user made a guess, we were appending it to our list of guesses. So we were appending our user guess to our list, user guesses list. And at the start of every round of the game, the user guess list is set back to an empty list. We start guessing the list again. Just to save a bit of time, I'm going to set the number of turns we've got in this game just down to 5, just so that we can run through a few games a little bit quicker and check that we have done everything and check that everything is working as intended. Oh, what have I done? Oh, I've collapsed my inputs. So this is a nice little chance to show you this. You see to the left of the far left of your VS Code window, if you're working in VS Code on a Jupyter notebook, when I hover over here, I get a little bar. Now, when I click on this bar, it collapses my code cells. If I click on this one next to the play button, I get all of my code back. If I click on this one next to my outputs, I get all of my outputs back. Worth knowing about, just because when you've got long code and actually you're working through it and you want to hide away some bits that you're not working on right now, then that can be really handy, but also worth knowing in case you click on it accidentally. So let us have a go at the guessing game. Welcome to the guessing game. They're thinking of a number, so I'm going to guess 4. No, this first time I'm just going to try testing out getting it wrong. And 60, so I've gone too low, I've gone too high again. Too high, I lost. Oh, interestingly, it thinks I got a new high score. I wonder why that is. And again, I forgot to put an F string. What is it with me today and F strings? Oh, no, I don't want to enter that number. I'm going to press escape to get out of the loop. So what worked here and what didn't? We got the new high score printed. Now, if score is better than high score, that suggests... So I think we want to print... Let's have an else clause here. So if the user didn't guess correctly at any point, then we've printed you lose. If the user does actually do everything correctly and does come up with a new score, then we're going to print your score. Let's do this F string this time. And we want score. And now I'm just going to move all of this bit inside this else clause. So it will only definitely trigger if the user has guessed correctly. So if they didn't guess correctly, they'll just get printed you lose. If they if they guess correctly and generate a new score effectively, then we will check at that point if their score is better than the existing high score, and we will update the high score to be the score if so. Otherwise, we'll say they didn't beat the high score and we won't make any changes to our high score variable. So let's try this one more time. Please enter a number. 3. Oh, what was our computer number? No, 72. So 5, 25, 104, and 103. There we go. So I guessed too high again. I lost. My guesses were 3, 5, 25, 104, and 103. This time I'm going to say that I want to play again. Now the number is 13 this time. Let's put a few guesses in so we will see if our score is iterating correctly. So I've got 1 incorrect guess, I've got 2 incorrect guesses, and I have then got, I'm going to guess correctly, 3 guesses, and that time my score was 800. Oh, I've managed to print the score twice basically. Oh, and that's because we did this inside here. We don't need that anymore. But that's fine. We know that's happening now. So we guessed it, new high score, and we haven't said what the high. Well, actually, that doesn't really matter. We could say new high score. Let's say we just want to say new high score. The previous score was high score. This will just make it a little bit nicer. The user will be able to see what the high score was and what they've beaten. We could do some nice things as well, tell them how much better their score was than the high score, but we're not going to do that today. So guesses, we've printed the guesses, and we're being asked if we want to play again. I'm going to click no because actually if we run it again now, we won't get any of the lovely benefits of our updated fixes. Now, before I go through again, I'm just going to quickly double check that we have done absolutely everything. Randomly picked a number between 1 and 100. User had 10 guesses to guess the number. Every time the user guessed a number, too low, too high, correct, we've done that. If they've used up all 10 chances, we're told you lose, that's working. We're told what the number was. Oh, we weren't told what the number was. So if we lost, if we did not guess correctly, we want the number was... and this is where let's check I can actually say computer, chosen number, make sure it's an F string. So now we're going to make sure that if they didn't guess correctly, we're told what the number was. The user used up on 10 chances. We've got the score, which is reducing by 100 for every unsuccessful guess and is being displayed when we win. We are storing the guesses in a list and those are getting printed at the end of the game. They are being asked if they want to play again after every game ends, and the score is checked against the current high score, and we're replacing the high score if that happens. So let's run this one last time. Please enter a number. So let's go 3. Let's just check that the kind of game not working logic, or the getting the incorrect answer, not actually ever guessing the correct number. Well, let's just check that's all working. So too high, you lose. Number was 47. This is what your guesses were. Do we want to play again? I would love to play again. So here we go. Please enter a number. So the number this time is, let's go 10. Let's go 50. Let's go 80. And we'll go 92. And there we are, correct, we guessed it. Our score was 700, new high score, the previous high score was 0. Your guesses were 10, 50, 80 and 92. I'm going to play through one last time just to check that our high score has updated as expected. So what do I want to do? I want to, I'm going to just actually try and win pretty quickly. So I'm going to go 85, I'm going to go 88. correct, we guessed it, new high score. The previous high score was 700, and those were our guesses. I'm going to say now, please let me leave. And everything has stopped running. Fantastic. So the last thing I'm going to do is I'm going to put a little hash symbol here before our debug statement. And what this will do is it will just comment out our debugging code. So now when we run again, that line will not print. But if we ever want to come back and tweak our code, we can just uncomment it again. It will run and we can make sure that everything is working as expected. So that is the Dan game. I'm just going to go through it very quickly again, one time from start to finish, just so that you can get your head around what this code is doing. So at the very beginning, every time when we first boot up the game effectively, when we first run this code cell, we set the continue play variable to true. We set our high score to 0. Now we enter the logic, which is one run of the game effectively. All of this is one run of the game. We set up an empty list to store the user's guesses in. We set up their initial score as 1,000, and we set that they have not yet correctly guessed the answer. We get the computer to choose a random number, and we print a welcome message. For the number of turns, and actually we'll change this back to 10 turns because that's what we're asked for. So we will loop through this bit of code up to 10 times unless they actually guess correctly. So we will have the user guess, we will ask them to enter a number, and we will add this to our list of guesses. Then we go through some conditional logic. We check whether the user's guess is equal to what the computer number is. If it is, we print a message. We set our guessed correctly parameter to true, so we can check against that in a minute, and we escape this bit of the loop. If they still had 2 turns left, 3 turns left, doesn't matter. We are escaping this bit and we are going on to this bit of the code. If instead the user guesses less than what the computer chose, we'll print too low and we'll take 100 off their score. At that point, they go back to the start of the for loop and they get a chance to enter another guess. If they enter too high, same thing, we take 100 off the score, we print a different message, but they go back to the start of the loop until either they run out of turns because we have gone through 10 loops of it and we're escaping it, or they enter a correct guess and we escape the loop. Either way, at some point we will come to this bit of code. We now check whether the guessed correctly parameter, the guessed correctly variable even, was ever set to true. If it was not, so if not guessed correctly, if that is still equal to false, which is what we set it up as at the beginning of the game, then we will print you lose and we will print what the computer's chosen number was. Otherwise, we will print the user's score, because otherwise the score would always be 0. Also, if they have guessed correctly, so this is the sort of opposites of the flip side. If they didn't guess correctly, do this. If they did guess, so if they didn't guess correctly, do this. If they did guess correctly, do all of this. So print what the score was, check whether this score is greater than what the high score was, and if so, print a nice message and tell them what the high score is. Otherwise, just tell them that they didn't beat the high score and tell them what the high score was. We'd already printed what their score was regardless, if they have actually won the game by correctly guessing the number. Finally, we go to this point. So regardless of whether they guessed correctly or not, this is the bit that is all dealing with did they guess correctly or not. At this point, regardless of what they did, because of this level of indentation, you can see it matches up with our if and else. It will always therefore trigger at this point because we are outside of this indented code. So we will print the user's guess list, all of the user's guesses, and we will check whether the user wants to keep playing. So we could ask the user at this point, we could try and cast y to, we could ask them to enter true or false, and we could try and cast that to a Boolean. I haven't done that. I've just asked them to enter y or n, and if they enter n, we set continue play to false, and we will escape this while loop. However, if they press y, we do not change the value of continue play. We leave it as true, which is what we set up at the very beginning of the program. And what will happen there is at this point, they will jump back to here, and the game will run again.